Hi, in this video, I'll explain basics of GPT and LLM, how GPT model works. Python implementation of LangChain we will illustrate in next section of this video, and then later on we will first find how this flow chart is working, how LLM works, what is the theory and agenda behind this concept. Then later on we will be finding setting up an API, how to generate text, how to create customizing the output, how we can summarizing text in part 3, and how poetic chatbot is there, and in part number 4 LangChain creation, and we will be using this query 1 and query 2 for my Teleperformance website. Let's see one by one what kind of procedure we are going to open. That's very much important here. So I'm going to illustrate a bit more about this point. Here you can see in this diagram we are having so many things, so many different architectures are there. Okay, so what are the architectures showing here? These architectures are generating these generation of it. First we had the GPT-1, it was originated in 2018. Then we have GPT-2 2019. In 2020 it was GPT-3 for context learning, and in Codex then we had in GPT 3.1 was originated in 2022. Then GPT 203 generated ChatGPT, which we are using currently, and these are all famous models. Here we can see, so these models are having text generating, and GPT turbo is a very important term. And nowadays we had GPT-4 as well. So this is strong reasoning ability, longer context window, a multi-modal ability, and this is a brief illustration of the technical evolution of GPT series model. So GPT generative pre-trained transformations are a family of large language models based on a transformer deep learning architecture. We have already defined transformers. You can go back in a previous video how we can go with this transformer models. Okay, so this is developed by OpenAI. These foundations models power ChatGPT and other generative AI applications capable of simulating human created output. Okay, let's see what other spots are there. Why is GPT important? Which is very important question being asked in interview or any other session. You can see why this is important. So you can say that GPT models have accelerated generative AI development thanks to their transformer architect, a type of neural network introduced in 2017 in Google Brain paper. Attention is all you need. It's a very important paper. Transformer models including ChatGPT, BERT, GPT and BERT have powered many notable developments in generative AI since then, with OpenAI's ChatGPT chatbot taking center stage. Here you can say a illustration of typical, you can say the data processing part is involving in this pipeline, and these are pre-trained large language models. First is raw corpus is there, then we have filtering and selection is there, which is involving various other resources, for example statistic filtering, keyword filtering. Then we have deep duplication stage, sentence, document, set levels, and then if any duplicate model is involved or any other things are required, then we have privacy detection, PI removal, PI, and so on. Personality identification information. Then we have tokenization. We divide every sentence or text into a small piece of code, a chunk of code, so that we can move ahead with further processing. Then we are ready to pre-train. This is numerical value which is ready to train for any machine learning algorithm or deep learning algorithm or transformers, because we cannot process this text data or words. So the underlying transform is a set of neural network that consists of an encoder and a decoder with self-attention capabilities. So the encoder decoders extract meaning from a sequence of text and understand the relationship between words and phrases in it. Okay, let's move ahead with this explanation here. Can you see these three learning models existing? First one is a zero shot learning, second one is a few shot learning, and third one is fine tuning, which is very important. Third one is very most important part of this ChatGPT generative AI. So this is based LLM can respond to a broad range of requests without explicit training, often through prompt, although answer accuracy vary. In few shot learning, we provide few relevant training examples. Base model significantly improve that specific area. But in fine tuning, this is an extension of few shot learning. In that, data scientists train a base model to adjust its parameter with additional data relevant to specific application. For example, you are working for Reserve Bank of India or any company like Teleperformance, for which we are doing this case study. So this is specific data for my company. So I'm going to train my entire LLM for this data set. So how this work? For example, you are going to translate English to Spanish. What is the time? So this is the output. This is kind of question in Spanish, that this is the English Spanish word. What kind of translation is being performed? What is the expected weather? So this is the weather in Puerto Rico in December. So in December, this is question and answer. This is question answer, and this is kind of questions, and this is kind of answer on our right hand side we have seen. So this is response from ChatGPT. So LLM is doing so many case study here. You can see, for example, you want to get a summary of this keyword in 15 words during extra messy and this, you are getting this summary. So on right hand side we have all these summaries here, and this LLM is kind of doing summary part for given text or given paragraph. Generating a tagline for fruit juice brand that is focused on sustain and organic farming. Yes, this is kind of again a good LLM application. Purely natural sustainability source, taste the goodness of organic foods with every sip. So this is kind of tagline generated by LLM. These are few done by LLM. So how LLM works? It just define these terms here. You can see it just provide the input and convert into tokenization embedding, and for example we ingest data in the form of books, train entire scenario in the form of books, Wikipedia, scientific research, crawling data set from internet, and other things are there, custom crude data set, everything there. Then we define this term with this entire scenario, and then I'm going to convert this data set into NER, name entity relationship and recognition. Then we are converting into numerical values and put words with similar meaning close in vector space, and then embedding functions are doing there, and when done well, similar words will be closer in these embedding vector systems, and then we are going to converting entire scenario into a similar vector format. Those are having similar meaning are going to keep here, those are having different meaning are keep apart from each other. So this is final output of my vector output. Finally it is converted into pre-trained transformator, billions of parameters are there, and this is the output text, and human feedback is also necessary, and this is the predicted coding. So then finally we will be decoding this part. Let's see, this is the resource which I have used in this PPT. You can find these documents in the description box or in my GitHub account as well. Let me open this references as well. So can you see this is the large language models, how it is working. This is taken from Databricks official website. You can scroll down, you will find everything here, how this entire version is converting, how these particular modules are working, how the evaluation is working, and so on. Thank you so much. In the next session we will see how setting up the API term. Thank you so much. Keep watching, keep learning.